In this video, we're going to look at a thermodynamics question from the engineering paper. Pause the video now and try all parts of this question. Part I, apply the first law of thermodynamics. So what is the first law of thermodynamics? Something along the lines of this. Obviously, the pluses and minuses do change depending on which direction we're going in. So what is happening here? Well, we're being asked to go from B to C. B to C is an isovolumetric change. The volume is constant, which means the work done is precisely 0 joules. So the change in internal energy is purely the thermal energy added, which means that that is equal to 700 joules, right, as we're told in this part of the question. Part II, show that 0.021 moles of air are taken through the cycle. So here we can use the ideal gas equation. We don't need to complicate it in any way. So what is the pressure? So the pressure 1.0 times 10 to the 5. What is the volume? 0.5 times 10 to the minus 3. What is R? This is the ideal gas constant. And what is T? 293, like it's told us here. So why have I picked these two values here? Well, it really doesn't matter. You just need to pick a set of points that are on the curve. Okay, if you pick any set of points, then this will obviously work. And I've chosen to pick this point here, point A. No reason for that. You can pick any point you want. So if you work this out, you obviously get 0.21 moles. Determine the work output of the cycle. So this is given by the area under the graph, or enclosed by the graph. So you need to basically count all the squares, right, which is very tedious. It's a lot easier to do on paper, where generally the squares are a bit bigger and you can actually tick them off. So what would you be allowed for this? You will be allowed basically an answer in this range here. All right, and that's from counting the squares. It's always useful to work out what one square is. And you can do that, obviously, by saying P change in V is the work done, and then working out for one square. This just guarantees you one mark in case you make a mistake counting the squares. And then finally, explain two differences between the real cycle and the theoretical cycle. So there's loads of things we can say here. So the obvious one is there is no exhaust or intake stroke in the real diagram. Sorry, in the theoretical diagram. So that obviously corresponds to some energy loss. There is no constant volume change. In the theoretical cycle, all right, because the pistons are always moving. But we assume that these happen, instantaneously in the theoretical cycle. What else is there? So you can also see there are no sharp corners on the real cycle. And again, that's because things like valves or processes take time to happen in real life. And finally, there will not be, and you can't necessarily tell this from the graph without further calculation, but there will be a lower temperature in the real cycle because of incomplete combustion.